Hey everyone, welcome back to my channel. Today we are diving into the super important topic for the web developers. What happens to your TCP connection after we have exchanged the HTTP message? So let's try to understand. So in the previous video we have learned that now the client, when it wants to ask for some resources, it establishes a TCP connection with the server. So once the messages and all those things are exchanged, finished, the server sends the response and everything is finished. So what happens to the TCP connection? So that is the main thing we need to understand. Let's say that we have sent a request, HTTP request, maybe a fetching a web page or something like that, and the server has sent back a response. Try to see it here, and the server has sent back the response. The message. So here the browser sends an HTTP request to your server. The server has processed the request and all the things, and it has sent the HTTP response back, and the browser renders the response. So here this is what it will happen. The messages are exchanged, but what happens to the TCP connection that carried them? Well, there are no trace of those messages left in the TCP connection itself. Means once the data is delivered, TCP doesn't hold on to it. It's like a delivery truck. It drops off the package and moves on. But here is the cool part. We can choose what to do with those messages or connection itself. Let's explore the two big options we have for the TCP connection and a neat trick called caching. So here what I would be trying to tell you is, for example, let's say that a request has been established and the response has been sent. So when the request and responsing lifecycle has been completed, so what happens to the TCP connection? So there will be two options only. Whether the TCP connection has to be destroyed, or otherwise TCP connection has to be established, has to be there like that only, so that the subsequent another request, when the client requests, so it can go with the same TCP request only. So that is the main thing. So now here if you try to see, so the one important thing which we can, so here this is the thing. So first is the close the connection, kill the TCP connection after each request response cycle, and establish a new connection for each request for the next request. Or otherwise maintain the TCP connection for the subsequent request, saves connection establishment time. So this is the another one connect. So adding a connection header, I will try to explain you about this connection header also. The first one which I want to tell you is the caching. So one option which we have is the caching. So initial request, when the client requests the resources, example CSS file or something like that, the server sends the resource and it will try, the browser stores the resource in the memory or the disk, and subsequently browser serves from the cache instead of making a new request from the next onwards. This is called as in caching. Because it is a game changer in HTTP. Imagine a client keeps asking for the same CSS file over and over here, something like that. Instead of sending a new request to the server every time, the browser can cache that file. When the server sends the CSS file in the response, the browser can save it either on the client's disk or in the memory. The next time the client needs the same CSS file, the browser just pulls it from the cache. No TCP connection, no new request, no waiting. It's super fast. It will be finished. Caching can happen on the client side like in your browser, or even in the server side also, to save the resources. We will dive deeper into the caching later, but for now, knowing that it's a way to store requests and response to avoid the repeating work. So that is the thing. Let's go on to the next one, is what to do with the TCP connection. That is the main thing, right? So our caching is done. So what we can do with the TCP connection? Let's focus on the TCP connection itself. After the request and response are done, we have two choices. One is closing the TCP connection. We can completely terminate it. If the client needs to send another request, we would have to establish a new TCP connection from the scratch and keep the connection alive. Let's say that the client wants to send a post request to /login with some headers. Means if we keep the TCP connection alive, the client can reuse the same connection. The server might respond with a status code, maybe some headers or even a token to confirm a successful login. No need to build the connection or something like that. It's already there. How to keep the connection alive? So there is a main thing. So how do we tell HTTP to keep the connection alive? Means it's all about the header called connection. So the connection keep alive. So here at the top you'll be able to see the connection keep alive. So using this connection keep alive, the header has two options. One is connection keep alive and another one is the connection close. So connection keep alive means this tells the server to keep the TCP connection open for more requests. Connection close means this is we are done, close the connection after this response. By setting this connection keep alive, we are reusing the same TCP connection for multiple requests, which is way more efficient. So that means it reduces latency, eliminates TCP handshake time for subsequent requests. lower the network overhead, fewer TCP packets for connection management, and significant time savings when loading multiple resources, reducing the server load also. Less processing required for connection handling. That is the main thing. So let's try to see with the real world example. So I will try to explain you with the real world example. So let's try to see it here. For example, let's say that here we are having something like google.com. Let's say that I'm having a google.com. So here I will be having a google.com. Let's try to inspect the element. So in the developer tools, if you try to inspect the element, so here you'll be able to see the thing. If you go into the network, so here I can, yeah. So here let's try to zoom in or something like that. Whether we can zoom in or not, I don't. Whether I can. This. This is here also I will try to do. So here we can able to zoom in here. So now if I try to go to the all, if I refresh this page, so here you can able to see the type of protocol. So here we are making around 5469 requests are being made. So each one is a request. If you try to observe here, the Google image is a request, and here this image, my icon is a request, and here this all the things are a request. If you try to see here the type of protocol, so here this one is an H3. H3 means it is an HTTP3 connection, and these are all H3 connection, HTTP3 connection. Somewhere you will be able to see the HTTP2 connection also. So this is the HTTP3 connection. So if you try to go with another website, something like Node.js or something like that, here we'll try to see what is the type of connection we're having. So here also some places we are having HTTP3 connection, and here we are having HTTP2 connection. So here some places we are having HTTP2 connection. So these are the different types of protocol connections which we are having it. Okay. And if you click on any of the resource, so let's say that let's go to the Google, and if you try to click on any of these things, something like this, here these are general. So general means the common things which you can able to. So the URL, the method, and what the server has responded with you. So that is the main thing. So this is the response address which the server has sent you, and these are the request address which the things you are trying to send it. Okay. And if you go to somewhere else with the fetch, that you can able to see all the request headers and all. So these are all the request headers you can able to see. So this is the things you are trying to send it, and these are the response headers it is trying to send you. So here you are somewhere you will be able to see the connection keep alive. Why? Because this one is an HTTP3 request. There is no need to send this one. So that is the main thing which I want to explain it to you. So let's go back to the PPT. So here, so real world HTTP request is Google search is making around 89. So like this we are having. So potential savings will be like this. So now, so I have shown you the browser developer tools. So you can open the developer tools, access through the browser menu, and you can see all the HTTP requests. Click on individual request to see headers, payload, and timing. You can see, and I have shown you those all results also. How we can see it. So normally the HTTP request generally you will have general information which will have the request URL, request method, status code, and remote address which I have shown you. And you will have the request headers which the client will send it to the server, connection type, user agent, accept types, and also the cookies. And the response address commonly you will have the content type, content length, server information, and cache directives. So these are things you will be having in a request response. And we are having, I told you right, we are having three types of version protocols. So first one is the HTTP 1.1. First line contains method, URL, and version connection keep alive header available. HTTP2 means methods in headers. So you will have the method in header. So here, but we here in the method URL version. So these are all the things available. So persistent connections by default. So there is no need to mention the connection keep alive in HTTP2. And here this one uses the quick protocol. Instead of TCP, it will use the UDP for performance and security. So the next one, what I would be trying to tell is, so connection management HTTP 1.1. HTTP 1.1 uses explicit headers to control the connection behavior. The connection header specifies keep alive or close. The keep alive header can set out time and timeout and maximum connections. So you can also have another header also. So when you are trying to send the header connection keep alive, Then you can also send another one, the something like keep alive header, how much time we should maintain and how much maximum connections it can make it. So here connection timeout is, for example, set timeout value. Keep alive timeout is equal to 8 means, that means, so for 8 seconds, if the TCP connection is open for 8 seconds, the exchange has not been happened means, then automatically the TCP connection will be destroyed. Track seconds for this last activity and terminate after the timeout period. So that is the main thing. And the next one is the connection limits. Server limited capacity for connection. So for example, let's say that you cannot have, if TCP connection is open means you cannot have a 1 million connections, something like that. The server will have a limited capacity for the connections. So here the maximum connections for you can make it is the maximum is equal to 800. So you can keep it like this. So then it removes the oldest ideal connections first. So that is the main thing. So that's it all about this one. So automatic connection termination. So when this TCP connection termination will happen is whenever you are trying to navigate to a different domain, or otherwise when you are trying to switch from Wi-Fi to cellular, or otherwise whenever the IP address is changing, then the TCP connection will be destroyed. HTTP to connection management. So by default it is persistent by default, so there is no need to keep the connection keep alive, something like that. And multiple requests share single connection. So this is the main thing in the HTTP2. Multiplexing is there. Multiple requests share the single connection only. Stream prioritization. Critical resources load first. So server push, server sends resources before the client requests. And whereas the HTTP3 connection means quick protocol, so built on UDP instead of TCP for faster connections. And maintain connection when changing networks also, it will maintain the connection. And reconnect to known servers without handshake. So without handshake, so you can also maintain the reconnect to the known servers. So this is all performance. New TCP per request, it will be something like this. HTTP1 it will decrease it, HTTP2 it will decrease, HTTP3 like this. Each HTTP version improves connection efficiency. HTTP 1.1 with keep alive reduces load times by eliminating connection setup. HTTP 2 and HTTP 3 provide further improvements. So that is the main thing. So resource types in the web request is, so HTML documents it can request, CSS, JavaScript, images and fonts. So these are the different types of resources the client can request from the server. So normally the content types and address will be something like HTML, it will be text/HTML, CSS means it will be text/CSS, and JavaScript means it will be application/JavaScript, JSON means application/JSON, images means so images/JPG, PNG or GIF. So port numbers in HTTP, by default HTTP unencrypted uses the default port 80 and URL format is like this, not secure for sensitive data. Whereas the encrypted one uses the 443 by default, secure for all data transmission. So that is what about this one. So key takeaways what we have learned is connection options. What are the different types of HTTP connection can be closed after each request or kept alive for reuse. And persistent connections we have seen, and modern HTTP connection use persistent connections by default with improved multiplexing. And connection server controls the connections through timeouts and maximum connection limits. So that's it guys about this one. I hope you understood about this connection, what happens to TCP connection in HTTP after the request has been completed. Hope you understood about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.